Hi everyone, welcome to the class of text analysis. In the last week or the week 1, right, we covered several issues or several things in text analysis. For example, we tried to cover understand what is text analysis and what are the steps in text analysis process. For example, it starts from problem identification, then data collection, data analysis and everything. Then also we talked about few cases through which we understood what is the importance and application of text analysis in business. For example, we talked about the Nike's case, the Domino's case and some other cases too, right? For example, Lenovo also we talked about it. Then we talked about the key techniques. Basically, they are used, which is used in text analysis. For example, clustering, topic modeling, and n-gram analysis. And what is the use, how they are used, we also briefly discussed about it. Then we talked about what are the key technologies that are used in text analysis. For example, like the technologies are basically programming languages that we use, for example, Python or R, or if somebody is not very good at programming, then they can also use cloud based technologies. So that is what we discussed. Then finally we also discussed about what are the text data collection approaches. For example, you may send a http request, or if you can't do it, then you can use go through websites like Apify, which is a very popular website used for text analysis. And finally, we also discussed about what are the ethical considerations in text analysis. So this is all we covered in the week 1, and I think that gave you a very clear insight, very clear picture, right, about what is text analysis, why text analysis should be done, and how, what are the data, how is the data available around you, from example documents we talked about, then social media platforms like reviews and all. So all these data are very helpful, which is used in text analysis. So in week 2, we will cover what are the steps in text analysis, then text pre-processing, text representation, feature engineering, and data collection, cleaning and pre-processing from a research paper. So and many more things we will discuss in this week. Okay. So this is how text pre-processing looks like. So as it says, before you get into any text analysis process, you have to understand what is text pre-processing. Now, what does text pre-processing mean? Basically, text pre-processing means the before you process the data, so some amount of some cleaning and some kind of purification of the data is required. Now, for example, here I have shown in this diagram, for example, lower casing, tokenization, removing punctuation marks, removing stop words, then lemmatization and stemming, right, removing numbers and even removing extra spaces, white spaces, right. All these are unnecessary for us, or we are not required for us, because they are not going to add any value in the data analysis. So they have to be corrected, this has to be removed. So this is what we do in the text pre-processing, right. So let's see some common steps. As I said, I showed you in the diagram. Let's see how it works. Now the common text pre-processing steps, we start with lower casing, for example. Now, when you collect the data, right, the data is in several formats and it is highly haphazard, maybe it is not cleaned data, right, because that is what the data is when you collect it from the different sources. Now, lower casing, it says convert all the text to lowercase to ensure consistency, because for any machine to understand it, there has to be a consistent approach, right. Otherwise, if there are inconsistencies, machines will not understand them, right. So, example, let us say hello world is now converted to hello world in a lower case. Okay. So, by keeping a consistent approach, it is always better and the machine will understand it. Second is tokenization. Now, splitting text into individual words or sentences. So, for example, you see I love NLP, right. So, now how it has been broken? Now, I 1, love second, NLP is third, and then you have an exclamation mark, that is the fourth. Okay. So, what does tokenization do? Tokenization helps you to break those into sentences into individual words, or break a document into sentences, so that you can extract meaning out of it. The third way of third approach is removing punctuations. Now, just any unnecessary symbol, you can remove it, because it is not going to add any value. Sometimes it has impact, it is not that it does not impact. For example, an exclamation mark sometimes is an act of surprise and such things, but then it is very difficult for us to explain that to the machine, right. So, that is why we remove those punctuation marks, right. So, unnecessary symbols we remove, hello world for example, and there is an exclamation mark. Now, what we do? We say just hello world, right. So, no exclamation marks now, right. The next is removing stop words. So, removing common words like the, is, and, that do not add much meaning is what is done in removing stop words. Now, you see, for example, if I say a sentence, right, and there are so many words, for example, they are used to frame the sentence, right, they are used to make the sentence, but actually if you see, we do not require them, they do not add any value. So, we can remove those words. So, for example, you see here the cat is sleeping. Now, the is unnecessary, is just connecting the two words cat and sleeping. So, what it is doing now, in while removing stop words, you say cat sleeping, that is all, right. So, all unnecessary words will be removed as a part of the text preprocessing. The next is lemmatization. Now, in lemmatization and stemming, they are actually part of the same process, but lemmatization is more effective than stemming. Now, what is lemmatization? Now, it converts words to their base or dictionary form, right. For example, you see here running. Now, running can be converted to run, can be converted to better, can be converted to good. So, whatever words you see in the dictionary when you open the word running can be converted into, can be considered as in lemmatization. Then next is stemming. Stemming and lemmatization actually in the same group, as I said. So, here also what you do is you reduce the words to their root form. Now, as I have written here, less accurate than lemmatization, right. So, it removes some suffixes like es, ed and ing. Okay. Now, the word running, for example, in stemming, in case of stemming, will reduce to run, even run. Studies will become study. Now, you might be surprised, what is study, studi, because it does not make a meaning. But the problem with stemming is that this is why stemming is less effective. It only removes the suffixes and it leaves, sometimes that makes less sense. Okay. So, that is why lemmatization is preferred over stemming, but stemming also has its own use. So, it will bring the word to its root form, right. The next is removing numbers. Many a times numbers also will not make sense, because we are doing a qualitative analysis, content analysis. So, for us we are talking about text data, right. So, we do not need numericals now. Eliminating numerical values if they are not useful. I have 2 cats, right, and if you have to write the number, then write it in the text format, right. I have 2 cats. Now, here I have 2 is removed and it becomes I have cats, right. But yes, the meaning is going away, but then in that case, that is the problem with text analysis. So, in case it is you want that 2 has to be there, then it could have been written TWO, right, instead of the number 2. Okay. The last is removing extra white spaces. Now, cleaning up unnecessary space is a part of the text preprocessing technique. Now, for example, you see hello, then world, and in between there are 2 to 3 white spaces. So, the machine will not understand. For the machine, any white space is a difficult character. So, it does not understand that. So, what it does? It says hello world with one gap as a normal word, right. So, now after understanding these 8 steps, let us go into more detail, right. So, what I have said, introduction to text preprocessing. So, text preprocessing, as I have already explained, is a fundamental step in natural language processing (NLP) that involves transforming raw text data into a structured and analyzable format. So, that is what we were saying, you will remove stop words, remove white spaces, remove those numbers, right, all these things. By pre-processing the text, we enhance the performance of the text analysis tasks, such as for whatever your purpose is. For example, you want to do a sentiment analysis, you want to do topic modeling, or for any machine learning algorithms. Pre-processing ensures that the text data is in the best form to extract the meaningful insights. Okay. Now, as I said, so text pre-processing, when you are cleaning or cleaning of data, So, convert to lowercase. So, we saw some examples. Ensures uniformity by converting all the characters to lowercase. So, let us see with an example. I absolutely love programming in Python. So, this example will carry till in further slides also. It is so amazing and fun, 100% recommended, coding life, Python rocks, right. Now, the machine will not understand many of these things. So, what does it do in the first step? Now, convert it into the lower case. Now, what has it been converted? The result is, I absolutely love programming in Python, right, keeping all the things as it is. It is so amazing and fun, 100% recommended, code, then hashtag, exclamation, hashtags, coding life, then again hashtag Python rocks. Okay. So, the first step is you have converted into lowercase. So, this example will carry in other things also, let us say, right. So, first improvement has become from normal text to lowercase text. Okay. The second, remove punctuation. So, eliminate symbols like exclamation, hashtag, etc., as they do not add meaning, as we have said. Now, this line that you saw here, read the result. I absolutely love programming in Python. It's so amazing and fun, 100% recommended. Now, here improvement is required, the punctuation marks has to be removed. So, how does it look now as a result? If you see, I absolutely love programming in Python. It's so amazing and fun, 100% recommended, coding life, Python rocks. So, all the exclamation and the hashtags have been removed here. So, now from here, if you see, now we will go for removing numbers. Now, removes the numerical values, as it says, if they are not relevant to the analysis. Now, I absolutely love programming in Python. It is so amazing and fun, 100%, 100 recommended, coding life, Python rocks, for example, right. Now, in the next line, what will happen? That 100 will be removed, right. So, if you can see here, we have removed those punctuations and then we have made the sentences. The next, we removed the number also, right. And after that, if any hashtag or a special word is there, that also can be removed. So, each step we are improving, right, our statement, right, and we are making it as bias or error free as much as possible. Okay. Once you have done the all the pre-processing techniques, right, then we get into those cleaning of those things, then you get into tokenization. Now, what is tokenization? Now, tokenization is the process of breaking down text into smaller units called tokens. So, like it is a token, each word is a token, right. Now, these tokens can be words, phrases or symbols and serve as the basic building blocks for further text analysis. Now, let us see, when you talk about word tokenization, for example, right, splitting text into individual words. So, you have a sentence, now you break it up into individual words, then each individual word will have its will be separated, so that the computer or the machine can understand and we can make some inference out of it. Like for example, what is the sentiment or how many times something is being repeated, whatever we want to do. Sentence tokenization, dividing the text into sentences. Suppose you have a big document or a paragraph, so you divide into several sentences, right. Okay. What is subword tokenization? Now, breaking words into smaller units, right. So, useful for handling unknown words or misspellings. So, these are some of the basic techniques we are using as part of the tokenization. So, let us see some examples. For example, analyzing customer reviews. The raw text is, I love the new features of the smartphone. The camera quality is outstanding, right. Now, this is a review somebody has given. What are the tokenized text words? I love the new features of the smartphone, all separated, right. Then you have a dot as full stop, that is also recorded. The camera quality is outstanding, and then you have an exclamation mark, right. Now, when it divides all this, it breaks into different words. So, what is the application? By tokenizing the customer reviews, a marketing or business analyst can identify frequently mentioned product features and sentiments associated with them. So, this will help you to not only understand the sentiments, for example, negative, positive words which are being associated, but also what are the most important words which are more frequently being mentioned by the customers. Another example, for example, you see in social media monitoring, the raw text is flash sale today, don't miss out on exclusive deals, hashtag sale, hashtag limited time, right. Now, what are the tokenized words? Flash sale today, exclamation, do, then NT, miss out on exclusive deals, then hashtag sale, hashtag limited time. Now again, tokenization helps in extracting hashtags and keywords to monitor campaign performance and trending topics. Now as you know, the hashtags are basically the trending topics, no, they which are the topics on which people are talking about it and all. So that is what helps you to understand in a better way when you are doing a social media monitoring. That's what social media is all about. So you want to learn what are the different topics on the social media which are most burning topics or most discussed topics. So that gives you a idea. Then we talk about stop word removal. Now stop words are commonly used words in a language such as the, is, at, the, which, on, etc., which are often removed during text pre-processing to reduce noise and focus on the main important significant words. Okay, let's see. Now how do you explain that? Now removing stop word reduces dimensionality and improves processing efficiency for during the text analysis. It emphasizes the meaningful words and contributes to the content, that contribute to the content. So only those words which make a meaning. For example, the, grammatically to frame a sentence you need it, but it does not add any value to a business manager because he will not make any sense out of it. So what does he want? He wants important words, for example, sale, happy, good, product, design, such kind of words, for example, promotion, all these are different terms which are used. So that can be useful, others are removed. Now example you see here, keyword extraction for search engine optimization. Now tokenized text, check out the latest collection of summer where all words have been separated, tokenized, right? And after the stop word removal, how does it look? Check is there, out is gone, the is gone, latest collection of is gone, summer where, right? So words which are not contributing are removed, right? By removing those stop words, marketers can identify the key terms to optimize for search engines such as latest collection, summer wear. Okay. The tokenized review, for example, the service was not good and the wait was long. For example, in a restaurant you have gone or a hotel and the review is the service was not good and the wait was long. After the stop word removal, how does it look? The is gone, service is there, was is gone, not is there, good is there, and gone, the gone, wait, was is gone, long, right. So what does it look like after stop word removal? Service not good, wait, long, right. Now the application is focusing on significant words helps in accurately determining consumer or customer sentiment towards the service quality, right. Then we were talking about also stemming and lemmatization. Now stemming and lemmatization both are featured in the same place because they have a similar kind of objective, right. So what is stemming does first? Stemming truncates words to the stem, right, by removing suffixes or prefixes which may not always result in a valid word. Now for example, running becomes run, runner also becomes run, runs also becomes run. So all the three are now going to their root word which is run. Okay. Now suppose you do a lemmatization. Now that is, as I have said earlier also, it is an improvement, it is better than stemming, right. So what does it do here? Now lemmatization takes reduces word to their base or dictionary form. So here it says, for example, better, the word is better. Now better, what is the dictionary other forms? Now good, right, running, run. So lemmatization is an improvement over stemming because it provides contextual understanding. Okay. Now let us see for content categorization, now stemming and lemmatization example. Original words were advertise, advertising, advertised, advertisements. Now after stemming, how does it look? Because advertise, advertise, because the last part is removed, ing, ed all are removed, right. So it looks like this. Sometimes they make less meaning also, less sense. But after lemmatization you see, now advertise remains the same, advertising also as it is, advertised becomes advertise and advertisements becomes advertisement. Okay. So lemmatization provides more accurate base forms, adding in categorized content related to advertising strategies. Now let us take another example about a customer feedback analysis. Now, the sentence is I enjoyed the interactive sessions. The session was enjoyable. I enjoy these webinars. For example, if I have to lematize how it would look. Now, I enjoy, ed is gone, the interactive session. Okay. Instead of sessions, session. The session was enjoyable, right? Now, I enjoy these webinar. So, the application of lemmatizing words, marketers can link feedback about enjoy and session to assess the effectiveness of their webinars. So, these are some advantages which lemmatization provides you, right? Now, what are the benefits of text preprocessing? It improves accuracy, reduces unnecessary noise because irrelevant information are removed and you can focus on the key content and meaningful patterns, right? Similarly, efficiency increases because it reduces the processing time and computational resources, right, through better optimized methods. And then it creates standardization because a consistent format for text data analysis enabling reliable results is what happens in this process. Then we talk about, today we will be talking about, even text representation also. So, what is text representation now? Now, text to numbers, right? So, for example, converting text into numerical features or called as vectors while preserving the meaning is an important task. Enabling the, it helps the computers to understand and analyze the textual data, right? So, some methods that we use in text representation are bag of words, TF-IDF, right? Word embeddings and feature engineering. So, let us look at them. What is first bag of words? Now, bag of words model is something where it all the words are kept in a bag, for example, simple meaning. So, bag of words represents a set of words and their frequencies ignoring grammar and word order. Each unique word becomes a feature in the model, creating a simple yet effective way to quantify the text. For example, let us understand. So, you can see this bag and there are several words which are in this bag, right. So, in practice, let us say text, there are two texts, the cat sat on the mat and the dog sat on the mat, text 1, text 2, right. Now, these sentences become a matrix counting each word's frequency. So, demonstrating how bag of word transforms text into numbers, let us see in the next, right. So, let us see how bag of words works with real product reviews. Now, original review are given to you, review 1, this product is amazing and easy to use. What is review 2? The product is good but not amazing. Okay. Now, in step 1, it identifies the unique words, step 2 counts the frequencies and step 3 counts create word frequency matrix. Now, the word frequency matrix shows how each review is converted into a numerical format where each word becomes a feature and its frequency becomes the value, right. So, you can notice how both reviews share some words like product and is, right, product and is, but differ on others, creating unique numerical fingerprints. So, let us see this. Now, words review 1, review 2, let us say the words are product is amazing, easy to use, the good but not, right. So, different words only we are taking. The product is amazing and easy to use. So, you got the product is amazing, easy to use, right, and the is here also, the is here, right. Now, the product is good. So, suppose there is repetition product 2 times. So, you do not have to do it 2 times. So, once only you have to write all the words for once, right. Suppose I have missed something, you can ignore that. So, product is amazing, all the words taken once only, right, are written down in this matrix and how many times they are coming in review 1 and review 2, it is marked here. Now, product review 1, review 2 both, right, both the time it is there. Okay. So, product is here, product is here. Then is there, is it there? Yes, both sides. Amazing, both the places, right. Then easy is there in review 1 but not in review 2. Okay. So, 1 and 0. 2, now 2 is there here but not in the other one. So, review 1 it is there, 1 0. Now, use again it is there in review 1 not in review 2. The is not there in review 1 but review 2 it is there. Now, the is not there in review 1 but here it is there, right. Similarly, good is there in review 2 not in review 1. So, yes, right. Similarly, you can do it. So, this is a matrix which helps to understand ki how, if you, as it says, it helps you to notice both the words which are coming, how many times they are coming and how they are affecting the entire review. Okay. Now, bag of words, the strength is that it is simple to implement and useful for small data sets. For small data sets, you can easily do it. But what is the limitation? It loses context sometimes, the word order, right? And results in sparse matrices, especially with large vocabularies. So, basically, you might lose the context. That is the basic problem. Okay. Now, TF-IDF, right? So, frequency, when we are talking about term frequency, inverse document frequency, so it improves upon the BOW. Now, bag of words. So, bag of words, as we said, is for small data sets, right? But when you have larger data sets, this is a better feature, TF-IDF, by weighing the word importance. So, it measures a word's importance in a document relative to a collection, right? Now, term frequency, frequency of a word in a document. IDF, inverse document frequency. Now, it takes the log of the total documents divided by the documents containing the word, right? Okay, let us look at this sample marketing document. So, there are three documents. Document 1, digital marketing strategies drive sales. Document 2, social media marketing builds engagement. And document 3, email marketing campaigns increase sales. Now, if I have to do a TF-IDF calculation, now what will I do? The term frequency is word occurrences divided by total words in the document. Now, and IDF is inverse document frequency, which is the log of the total docs divided by the docs containing the word. Now, if I do this, for example, word occurrences, right? Now, how many times the word is occurring in a particular document? Okay. Now, for example, marketing. If you take the word marketing, now in this document, marketing is occurring only once. Okay. So, when I do a term frequency calculation, so marketing, for example, as I have mentioned here, marketing appears only once in the total document. So, 1 by 5, right? And so that means, and my IDF is log 3 by 3. Now, why 3? Now, if you see, now there are 3 documents and this is total documents is 3 and documents containing that word marketing is again 3. So, 1, 2, 3, 3 documents, all the 3 are containing it. So, log 3 upon 3 is 0, right. So, therefore, my term frequency IDF, right, inverse document frequency is becomes 1 by 5 into 0, which is 0. So, TF-IDF calculation for sales, now similarly you can also do it. Now, 1 by 5 because appears once in 5 words in the first document. Now, for the second IDF part, it is log 3 by 2. Now, 3 documents and in 2 documents only sales is visible, one here, right, and another is here. So, when 2 times it is showing, so log 3 by 2, which is 0.176, right, and the total value now TF-IDF becomes 1 by 5 into 0.176, which is 0.0352, right. Now, this example shows how TF-IDF assigns higher weight to words that are unique to specific documents like sales, engagement, campaigns, now in comparison to common words like marketing that appears in all the documents. So, this helps to give you a very clear insight or clear understanding of what are the most important terms in this document, right. And that is what we do in text analysis. This word is more important. For example, sales is a very important term. You can do this, for example, let us say if you want to calculate, let us say for some other word, for example, let us say strategy, for example. Now, strategy is coming only once in these 3 documents. Social media, for example, how many times it is coming? Only once, right. Similarly, campaign, how many times campaign is coming? Only once. So, some words are coming once, some words are coming multiple times. So, it tells you basically, by assigning higher weights to the unique words, it gives you a very clear or better picture, right. So, with this I will also try to understand what are the strengths now. So, strength and limitations if you see of TF-IDF is, the strength is it highlights the important terms, reduces weight for the common words. So, common word was marketing in that case, and limitation is it computationally very expensive for large data sets or large documents. So, that is the limitation. Otherwise, TF-IDF is better than the bag of words as we have mentioned, right. So, I think you have understood today about what is text pre-processing, what is text representation, right, and how they are useful for any researcher, right. With this, we will wind up today's lecture and we will continue in the next lecture from where we have left today. Thank you very much and take care. Thank you very much.